Welcome everybody and thanks for joining this session. My name is Antonella Sanguineti and I'm heading the product line Optical in Ericsson. And the scope of this very short session today is to debate about the role of optical and packet networks in the 5G architectures. So we know 5G is a reality now. We have so many installed networks today. And what we have learned from this experience, first experience, is that in reality, they are not only 5G networks. So in the network that have come out, there is a mix of technologies, 3G, 4G, and 5G, as well as a mix of macro sites together with small cells and street macros. This is why we call it ubiquitous RAN, because in this portion of RAN network, there are many technologies and different kind of radios and basebands. And they have some characteristics. So the new spectrum comes with high bandwidth demand. There are coordination features that now are not only within the site, but also intra-site, among different sites to achieve better performances. And there are new split architectures, so new way of implementing this RAN network. And the Cloud RAN is just an example that Ericsson launched a couple of weeks ago on how to build networks according to a new paradigm. And these things have an impact on the transport network. We are talking about the transport being able to carry more capacity with better synchronization, fulfill more latency requirements. And it's not only about that, it's also about using the available media at the maximum extent, whether it is fiber or microwave, be able to maximize the existing infrastructure, requirements on footprint and installations, and automation, of course. And these are the aspects that hopefully I'm going to cover in the next slides. First of all, let's define what do we mean by RAN transport. For sure, and let me use my pointer so it's easier, for sure, it includes the backhaul network, so the transport that carries the traffic coming out from the baseband, whether it is IP, microwave, or optical, we call backhaul network. But then we are talking also about the new segment called fronthaul. If the radio and the baseband are not co-located, there is a connectivity here that we call fronthaul and carries CPRIs or eCPRI signals. And with the 5G networks, it will be a bit of a mix of all of them. We can find networks that have backhaul, fronthaul, and also some kind of new connectivity that we call here mid-haul, but is the connectivity between processing or virtual processes of the radio functions. So backhaul, fronthaul, or whatever connectivity between the radio functions is what we call the RAN transport. Having this in mind, let's just have a look at these requirements that come from the radio. In this picture, you see the urban areas, the suburban areas, and the rural that have different requirements in terms of RAN. And let's start looking, for instance, at the traffic density. So you can see that whether you are in the urban area or you are in the rural, there is a bit of a gap between the traffic that has to be carried from the transport network. It shifts from 25 gig and more up to hundreds of megabit. This is why the point one of my requirements states scalable backhaul or fronthaul capacity, because it has to carry this capacity in a very efficient way, so that it is cost effective and able to flexibly switch between the different demands. If we focus a little bit more on the rural, on the dense urban areas, this is where the NR spectrum or the massive MIMO is not only about high capacity, but for instance, we see different kind of architectures there, not only the distributed RAN, which is very popular, has been very popular with the 4G, but also, for instance, centralized RAN architectures for the sake of space, of power consumption, or also for coordination. And transport in these areas has to be able to allocate and to arrange all these architectures. I mentioned coordination, which is our point 3. Of course, RAN coordination means synchronization, latency, quality of service for our transport network. And if we mention synchronization, it's not only about coordination. For instance, a number point here focus on TDD networks that require very precise time and phase synchronization, or the Ericsson spectrum sharing feature require very good coordination from the transport perspective. We cannot miss the security. Let's think about the 5G network where you have small cells and street macros in untrusted areas. There it's pretty evident that security must be at any level. Radio for sure, but transport has its part. I will skip latency. We will touch it so much in this presentation, but definitely latency. If you have to accommodate many different services into this 5G network and very critical services as well, latency must be really under control. And then, I just wanted to jump on point 9. The new architectures, and in particular the Cloud RAN, will imply that the transport network has to carry not only the legacy services from radio, the CPRI signals, but also the new services, the eCPRIs. So Cloud RAN implies that you also are able to convert the legacy traffic into Ethernet so that it is easily manageable. And then on top of this, our point 10, there is the expectation that the 5G comes with more efficiency than the previous Gs in terms of management system, in terms of automation, in energy consumption, and also resource management. So we definitely agree with what our CTO stated, that superior RAN performance implies superior RAN network. They are very strictly connected. And just to emphasize these aspects, I will use this slide. And reasoning about a logical E node B. What is it? Till recently, an E node B could have been represented by this small bubble gray here, where you have the radio and you have the basement, and that's all. But now, with the advent of the new architectures, for instance, the cloud RAN or the C-RAN, look at here. The C-RAN, in the C-RAN scenario where you have the basebands that are not co-located with the radio, you see the role of this link in between. This is transport. And this is have a very relevant function to carry on in order to make the performance of the radio at the right size. And this is even more relevant here, more evident here in a Cloud RAN architecture where the baseband processes or the RAN processes are split into different locations, one very far and one into the middle. And these links, whether they are microwave or optical or packet or combine them, play an important role here to ensure the radio performances. So I started with the title of this presentation talking about the new role for transport, not because transport was not been important previously, but here is really a shift of paradigm. It's not only about carrying the radio traffic anymore, it's about transport being an integral part of the radio performances themselves. And now, let's go a little bit more into details. What do we mean about requirements? What kind of functionality the transport network has to carry? We stated previously about flexible capacity, and this means being able to carry 10 gigabit today, 25 gigabit, 100 and more in the future at a very low cost in an efficient way. Because it's not all about the speed, it's about the right speed for the right performances and mainly for outdoor environment, because high temp requirements are absolutely mandatory in the RAN ecosystem. When we talk about the performances, we mentioned already, definitely low latency systems able to carry traffic with the proper delay and jitter. Best synchronization, we cannot compromise on synchronization for sure. The transport needed to have a good quality of service functionality in order to accommodate the different services with the right priority. And then, last but not least, traffic integrity and security. We stated previously, there might be cases where this is absolutely mandatory. But I want to focus also on other aspects that sometimes are a bit neglected. And I want to stress the importance of RAN integration. And for instance, look at the design. It is important that the transport design is optimized to go together with RAN, because the network, which I call the ubiquitous RAN, implies ubiquitous transport. And then the density of these networks will be so much, or will be so high, that it's important that the transport and the RAN have a common building practices to make installation easier, to make maintaining the network much easier, and also to the look and feel to be better. Common management, common orchestration, this will become a must. And then I stress the point again, high density. The network will be super dense. So it's important that we optimize the components to carry as much signals as possible. And we don't need to forget the TCO. I come back every time about cost, but If we want the whole 5G ecosystem, transport and run to fly, it has to be easy to install, NRO must be slim, and also the maintenance of this network has to be secured. And I'm very keen on these tools that allow the operators to have preventive maintenance instead of going to the site upon emergency. So it's better if they can plan the access to the site and keep the cost of the network down. So these are talking about these requirements. And now I just wanted just an example to make a game. What happens if these requirements are not satisfied? It's very easy to list what the transport network has to do, but it's also important to understand what happens if not. And I will not go through all of them, but if we just start with the capacity, what happens if the transport network miss a number of CPRI frames or EC pre-packet loss happens? Let's consider this connectivity in a centralized RAN architecture where you have the radio and baseband and the link in between. What happens if capacity is not enough in this link? The radio link could go down easily very well. Or what about if the link is too fat because we have over-provisioned this in order to be secure that we don't miss any single bit? Then the cost of this piece of the network will be so huge that it will not be sustainable. The same is for latency or synchronization. If I burn too much latency in my link, in my transport network, then the radio performances might be degraded. Or if I don't have enough synchronization, I may even lose the radio link here. And again, about footprint and TCO. I mean, what about if the transport equipment are too big and they cannot be accommodated in the hub or in the remote poles? Or if their design is not good enough, so that municipality don't give the permits to be deployed in the visible poles. All these challenges we have faced in our experience in 5G networks. It's very important that we look at these requirements. So transport is as important for radio as I'm mentioning, because it's an opportunity for the radio to perform better, but also challenging in terms of carrying the requirements that we have listed. Okay, hopefully we have very clear in mind which portion of the network we are talking about, which are the requirements. And now let's have an assessment of whether optical and packet are suitable enough to cope with the 5G requirements. The answer is yes, I tell in advance. But let's go through all of them. If I look at the optical and I look at the capacity, definitely, and for instance, DWDM is an example, you can combine as many frequencies, as many lambdas into a single fiber strand that you can really optimize the usage of the fiber that is in field. And we know that fiber is becoming a very scarce resource. So capacity is definitely well managed by the optical technologies that we have today. If you move to bandwidth, I listed here 10 gigabit, 25. To me, the importance is not about the line rates only, of course, but the beauty of that is that today we have available line interfaces for high line rates, 25, 50, 100, and even more, that are compatible with existing frequency grids. This is the beauty, because if you have an installed base with filters that have been deployed a couple of years ago, 10 years ago, for 2.5 or 10 gigabit networks, they can easily accommodate the 25 gig traffic of today. This allows a smooth migration from traditional transport network to networks that can cope with the 5G advent. Another important aspect is outdoor requirement, high temp. And I'm very glad to hear and to see that the ecosystem now, the optical ecosystem, is taking the mobile requirements into account when defining the products. So now we have really pretty soon, with respect to the C-temp, very good components that perform really well in outdoor environments and not only in the C-temp. And this is key, as I mentioned previously, for RAN transport. I will be fast on flexibility, because we all know that optical components, whether they are fixed or they are reconfigurable, they are so much available to cope with any fiber topology. So it's just a matter of combining the right components that are available. I will stress the latency. We know that optical is a perfect technology to have low latency connectivity. Packet optical bypass, optical bypass is becoming more and more popular to ensure that some pipes or some services have direct connections at low latency in optical domain without going to the electrical domain. So definitely latency is a plus for the optical assets. And then if I look at footprint, definitely optical is very suitable to be miniaturized. So it copes very well with the requirement of accommodating the transport devices, the equipment together with the RAN ones. I will not stay too much on this optics evolution because here the message that I wanted to give, and I know that there are many sessions in this ECOC that can explain all of this much better than I do, but what I wanted to say here is that whether we are in the front haul or in the back haul or even in other segments, the optical ecosystem is following the requirements. I mean, whether you are in a bidirectional or a gray optics, or we go more into the DWDM, we have components with super good performances and pretty efficient at 25 and moving forward 50 gigabit and 100. And also, if you look at the higher scales, 100 gigabit, 400 gigabit is available to fulfill any demand that these 5G networks may have. So we are totally comfortable in terms of optics and optics evolution. I will stress once more the importance of keeping the total cost of ownership of the optical networks in the RAN domain and also the automation trends that we are experiencing. I will start mentioning the fact that we need simple networks and simplified operations comes with commonalities. So we as Ericsson think that velocity and quality require common building practices between radio and transport. So we think that this is a very important ingredient on how to build the RAN transport networks. I mentioned already that there are in the 5G installations a lot of variety of fiber plants and a mix of packet, micro and optical. So modularization is very, very important to have deployment flexibility. Just because fiber plants are not all the same, and so modular solutions increase flexibility a lot. And then we like the idea that even in frontal networks that so far have been very, very static and static, tunability of the optical components could be the next frontier of automation, not only reducing cost for spare part or for deployment and installation activities, but also is really the first step towards an automation and orchestration in these kind of networks. So optical is definitely a very good go ahead for the 5G transport networks. Let's have a look at the packet now. I mean, it's definitely easy to say that packet and packet protocols, whether they are IP or Ethernet, they have all the tools to fulfill the 5G requirements. I stress here the point of synchronization, whether it is a class A, B, or C, depending on where you are in the network, but definitely they are available on the market, and we have as Ericsson in our routers and switching families, a very good example of best synchronization for our networks. In the packet domain, quality of service is essential, and here hierarchical QoS is more than enough to ensure that all the services can be perfectly scheduled and queued and are treated according to the right priority. So HQoS is a fantastic tool in this case. Segment routing, definitely the best protocol for enabling orchestration and automation through SDM controller, and it is very mature nowadays, so it's really there to enable very good 5G networks. And then last but not least, CPRI conversion. I mentioned previously, if we want the packet network to be ready for 5G, it has to be able to carry not only the new eCPRI traffic, but also the legacy one. So being able to convert the CPRI into Ethernet, whether it is with radio over Ethernet or with real conversion, which we have as Ericsson, is important to be able to convert everything to packet or Ethernet, so that then you can carry this over a packet network, and it's available today. So just to conclude my speech, we have assessed the IP and optical technologies with respect to the 5G requirements. Both of them are suitable, really very well suitable for the task that they are assumed to do. There can be alternative technologies for front-haul, backhaul, mid-haul, or they can be even combined to have the best of the two worlds. But definitely, they are ready to go. So my takeaway for this short session is it's evident that RAN and transport have to evolve together if we want to fulfill the 5G requirements. There are challenging transport requirements, but definitely optical and packet technologies are ready to cope with them. There is not just one solution fitting all. This is why our suggestion is just let's use the technology and mix and merge them to achieve the best results. And then automation and simplification will be the next essential to make this happen. And with this, I just thank you all for attending. And if you have any questions, just contact me and I will clarify offline.
Oh, thank you very much, Antonella. Very interesting presentation, really enjoyed. We've got plenty of time for some discussion. I haven't seen anything in the chat so far, but I would encourage you to ask questions. Maybe a question from my side. So there is a lot of initiatives on Open RAN, where also and also Tip talked about it, of course, that disaggregation and multi-vendor interoperability is something some operators are looking for, to achieve more flexibility. And now looking at all your requirements, and which I fully support, how do you think would these requirements in terms of latency, in terms of this installation things and so on and so forth, be affected by opening it up through Open RAN architectures and multi-vendor interoperability?
Yeah, I mean, there are different aspects that are to be covered when talking about interchanging bit and pieces of these networks. I think it will be a trend, and let's say like this. Requirements, the more we get experience on the different sides, both in RAN and transport, but mainly transport, the more the requirement will be part of our DNA on how we build things. I don't think there is nothing strictly related to a specific architecture, whether it is DRAN or CRAN or vRAN or Open RAN and so on. So these are requirements that will run in parallel and smoothly if the ecosystem follows as it is doing. I'm looking from the optical perspective. I see more and more standard interfaces into the optical components, and also efforts to align the building practice, to have compatible building blocks. So that will just follow the trend.
Mm-hmm. Okay, yeah, makes sense. So are there any more questions from the audience? I don't see anything right now in the chat. Yeah, that's maybe the drawback of this format, right? Yeah, that in a session it's easier to ask the question, whether it's here,
Yeah, or they needed to just to digest a little bit, and so we will see.
Yeah, right. Yeah,
questions coming out in the next days.
Exactly. I like it always that maybe they come back to you later. Yeah. All right. So if there are no more questions, so thank you again. It was really interesting. Yeah. Thanks for joining the Market Focus here again. Yeah.
And thanks everybody. See you.
Thank you. Thank you very much. And I hope to see you later at the afternoon session again. Thank you very much.